Right, so we've got this little program. They actually use sensible labels for everything. In this, not many times do they do that. So we've got like red light, green light. We got max. We got, once we see that in the code, rather than it being just numbers for the addresses, it's these symbols instead. It makes it a lot easier to read. Okay, so looking at the question says, fill in this massive table. I don't know, bit mean to make you do so many of them. And the marking scheme was pretty brutal. It was, you got the first 4 right, you got a mark. Got the last 5 right, you got the other mark. So you could have messed up just 2 and got nothing, which I think is a bit mean, but hey, I don't have control over any of that. Right, so in order to do this, we've got to follow it through. Now, I'm not going to work through the whole thing. I'm not going to do 9 attempts at this. All I'm going to do is I'm just going to, what was it? It just went through the numbers 1 to 9, didn't it? So I'm just going to do it while I've got it on the screen with one. You can look at the mark scheme if you want for the actual final versions. Now, to trace it through, we've got to keep track of 2 things. Where we are in the code and what the value of the accumulator is. Okay, so we can use our finger to work out, our finger can be the program counter, but we do need to keep track of the accumulator. So I'm going to run it with 1 first. Right, the first instruction, input. Gets input from the user and sticks it where? In my computer. Where does the input go? Nope. I'm just doing 1 instruction at a time, Avery. You jumped ahead, man. What does input do? Right, it puts whatever value has been inputted into the accumulator. So the accumulator becomes 1. Right, we have got entry, and I'm going to use this down here to do this. So it says STA entry. So whatever's in the accumulator, put in the location entry. So I'm actually going to put entry up here. My pen's gone back to black, I don't know why, but right, so what ends up in entry is a 1. I don't know where that is in memory, but it doesn't matter because I'm just going to use the label to refer to it. Right, it then says load to the accumulator whatever is at location max. So at max we got 5. So a 5 will appear in the accumulator. It then says subtract. So subtract from the accumulator whatever is at entry. Now entry had a 1. So when we do that subtraction, as long as you don't mess it up, hopefully you get 4 in your accumulator. Easy to mess up. I've messed up things worse than that in front of you lot, I think, most of the time. There you go. Right, it then says branch P. What does branch P do? Positive, yeah. Remember, 0 they count as positive as well. So we branch to accept. So that means the program counter is going to get set to whatever accept is. So we're going to end up jumping to this line because that is positive. So it says LDA green light add what in it? 1. So a 1 goes into the accumulator, and then it said out. So our output for that first run is a 1. Okay, and for me, for my sanity, I might put next to it green light. Okay, so they didn't give you room to do all that tracking, which I think was a bit off, and they shouldn't have asked you to do the same thing 9 times just to test that you could follow the code. Right. That was the process. Let's pick one of the other ones. Let's do 7. So let's just do the same thing starting with the 7. I'm just going to do a squiggle and just carry those down. Right, so I do input, I get 7 in there. We store that in entry because that's what it tells us to do. Then we load up the value max, which is the maximum number we're allowed. We load that to the accumulator. Then we subtract what we entered. So this time we get -2. And then it says, right, okay, branch positive, accept. Well, that ain't positive. So we're not going to follow that branch. We carry on in sequence. Okay? That's what the program counter's used. It follows a sequence unless a branch instruction tells us to change the flow of the program. Right, so the next instruction after the branch, because we didn't follow the branch, was load the value of red light, which was a 0. So that goes into the accumulator. And then it adds BRA, print and end. So a BRA is what we call a absolute branch. It always happens. Branch always. Okay? Unconditional. There's no condition attached to it. So we're just going to do that. So the program counter changes. So we skip this instruction. If we didn't skip it, we'd end up setting a green light. So we go to there and we output a 0. Okay? How many people guessed what it was doing and just filled the table in? Good. Don't ever guess, because there might, if I was writing the code, I would write this code to screw you up if you did that. Okay? Right, okay, move on then. It then got this bit. This is the bit that most people did pretty badly because you did it too superficial. Right, explain which registers and buses are used and the values they store carry when the line LDA red light is executed. Now, the critical bit is in brackets. After it has been fetched and decoded. So we've got everything we need and we're just about to execute that thing. So we would have the PC and the accumulator set up. Right, LDA red light. So what would be in the accumulator? What would have been... Do we know what's in the accumulator before we execute this? Does it even matter? Right, I don't know what's in there. I have no idea. LDA red light is on that line. I actually don't even know what the PC is. So the PC doesn't matter. Okay, we don't know what the PC is. It does not matter. We're actually going to perform the execution. LDA red light says fetch something from the address given and put it in the accumulator. So to execute this instruction, we need to access that address. Yeah? So, in order to access address, what register do we use? If we want to access a memory location. Right. So our first step is going to be place address of red light. Whatever that is, we don't know what it is. So we can only refer to the names into the memory address register. That's the first step. Then we can execute a fetch. So we can then do a read via data bus. Now, on Little Man Computer, they don't have a memory data register, do they? Where do things automatically go when they're fetched? They end up in the accumulator. And the value at red light was a 0. Okay, so really what I should say there, if it wants to know about the bus, it should say transferred over data bus to memory. Why do I not say RAM? Why do I say memory and not RAM? The CPU doesn't know what it's accessing. It's got this thing that it's got an address bus for. There is a memory management system that will work out whether that is in RAM, ROM or cache. Okay, so if you're just generalizing, you should just always use memory. The stuff that's connected to the CPU. Whether that is RAM, ROM, or cache is up to the memory management system. Okay? Usually it's on chip with the CPU these days, but it didn't used to be. It used to be a separate chip. Another point of delay that we used to have that we don't have anymore. Okay, so you've got to make sure you give detail. It's important that you can describe in detail how each Little Man Computer instruction is executed. Okay, I think... Oh, then we had the last question. Right. A note. My general note on this is you do not have to copy literally what the Little Man Computer program is doing. You can do. You can follow it line by line and do something in a high level language. But what this program is doing, and if we look at the just the description for part B, wherever it was, just above the code on it. Right, it said part of a coffee making machine asks the user to press a button to select strength. The code outputs a 1, which will switch on a green light to indicate a value selection, or outputs a 0 to indicate an invalid selection. What's the maximum value we can put in for our strength? Looking at this program. And they've been generous to us because they've named things carefully. What's the biggest number we can put in? Anybody? Nobody? 5. If we put 6 in to this code, we'll get a negative number. Okay, when we execute the subtract. That generates a red light. If we put a 5 in, we'll get a 0. But that still gets accepted by branch positive, because 0 is counted as positive. Okay, so 5 is the maximum number. So I'm not going to literally copy the Little Man Computer thing. I'm going to write this code dead easy. You'll always get a mark for doing the input. So I'm just going to say strength, that's what I'm going to call it, equals input strength. So I'm just going to put a nice question to the user so they know what they're inputting. And then I've just got to decide whether it's bigger than 5, then I'll put a red light out, or I'll do a green light. So all I need to do is if strength is less than or equal to 5, output green light. Now a few of you put a 1 and a 0, which is fine because that's what it did, but actually because this is pseudocode, you know, that's all they wanted from you. It's just an input and an if. There was no loops involved, so Little Man Computer, there was no loop. So it was just purely that. This is why we don't use assembly languages much anymore, because high-level languages are more obvious. It's clearer, it's easier to write, and it's easier to read back. If they'd have given you that question and said, what's the maximum strength, you could have answered that question immediately. You didn't need to set max to 5. Some load of you did that. You had a variable called max, which is fine. But you know, I could have done that. So I could have rewritten that. I could have gone max equals 5. A lot of you did loads of subtractions because that's what the Little Man Computer did. So you made it overcomplicated for you and the marker. So I could have replaced that with max. That would have made it more readable, but I didn't need to. Okay? But it isn't about literally copying the Little Man Computer. It's about what is the observable actions that the code's carrying out. Okay? That's a practice thing. The best way to practice that is to look at all the Little Man Computer problems that you've got and just try and write them in JavaScript. Be good practice for your JavaScript as well. Right.